Our research is broadly classified in the domain of bioengineering, and within bioengineering we work primarily on the application of biomaterials for two broad areas. One is tissue engineering and the other one is controlled drug delivery systems. So tissue engineering is sort of trying to artificially make human tissues, and so one has got a large number of tissues to make, but our focus is on musculoskeletal tissue engineering, more so specifically cartilage, bone, ligament, and the interface between two tissues such as cartilage and bone. The other area that we work in is controlled drug delivery systems, wherein we primarily work on micro and nanoparticle based drug delivery systems, and these can be for multiple disease conditions. So the applications of these two broad areas are primarily in two main domains. One is in tissue engineering we work on mostly tissues that are related to the knee joint, and our focus has always been on cartilage, ligament and bone in that knee joint, and this is also oriented towards a disease, osteoarthritis. So if successful, we would have a methodology that would lead to tissue regeneration, primarily cartilage, ligament and bone tissue regeneration, which will finally eventually provide a new methodology for treating this disease condition. In the domain of drug delivery systems, we're working towards diseases like diabetic retinopathy in the eye, which is otherwise very difficult to reach since it's in the posterior eye. And these very small nanoparticulate drug delivery systems can be used as eye drops and non-invasively treat such a condition and does not require technical expertise. So therefore it becomes a very useful sort of technology development. Similarly, classical treatment of cancers involves chemotherapy, and chemotherapy is typically given intravenously, and hence it can affect have side effects on multiple organs in the body. Whereas the delivery systems that we are developing, they will be targeted delivery systems, and hence they carry the chemotherapeutic agents and deliver it only to the targeted desired tissue, which is in this case cancer. And hence all the side effects are circumvented, and more importantly you get a very efficacious treatment of the cancer, which also makes it affordable, which is important in the context in India. And then we have a vaccine delivery system. Now this diarrheal condition that I'm talking about is shigellosis. This condition is predominantly endemic in developing countries such as India and Africa, and unfortunately there is no vaccine available for this condition, and it badly affects children under the age of 5, so much so that it can cause death. Now unfortunately, because of the non-availability of a vaccine, the current treatment methodologies are at best can try and save the lives. But this vaccine, if successful, would actually be very effective and useful in developing countries. An added advantage that we are providing here is something which can sort of circumvent the need for this cold chain requirement. That is, this is temperature stable at higher temperatures, and therefore this would also help in tropical countries such as India, where common temperatures are in the 20s, 30s and 40 degrees. And the last application that I want to talk about is taking the tissue engineering strategies in osteoarthritis forward. We are in the process of trying to even develop drug delivery systems for osteoarthritis and sort of provide new drug systems that are modifying the disease itself, which are currently not available. So if we can do that, then we would have a very interesting way to treat the disease condition. Right now, there is no such treatment available. So these were the few examples of our applications. So the chair position has been a very strong encouragement to strive to do high quality research that can be eventually translated as technology to improve healthcare and therapeutics in humans. The chair position has also been a very strong driving force to try and be the best possible version of myself as a teacher, as a mentor. I wish to take this opportunity to express my deep sense of gratitude to Mr. Ravindra Nath Akhoury, who happens to be an alumnus of IIT Kanpur and who has instituted this in memory of his parents, the Gireesh Jankinath Chair Professorship. Such a chair professorship, I think, will go a long way in terms of fostering excellence in research and teaching, which forms the foundation of institutions such as ours and any other academic institutions like IIT Kanpur.